Okay, I'm going to go ahead and put that answer up so you can kind of follow along if you're not done. So completing the square, that was as good as I could write with the mouse. So the first step is to get that empty space, so you subtract 10 over, and then you divide out the one that's in front. You keep it in the front right there. And then you start your cycle. So you take the 7 and divide it by 2, so that gives you 7 over 2. Then you square it, and that gives you 49 over 4. But we made the 49 over 4. That wasn't part of the original problem. So to balance it out, we have to add 49 over 4 to the other side also. So that just gives you 9 over 4. And then to solve it, you square root. Square root causes the 2 to cancel. And then you subtract the 7 over 2 over to get x by itself. So in the green over here, you've got negative 7 over 2 plus 3 over 2. That ends up giving you negative 4 over 2. But if you reduce that, it's negative 2. And then you've got negative 7 over 2 minus 3 over 2. That gives you negative 10 over 2. And then if you divide that out, it gives you negative 5. And again, if you would have just factored it, you would have got x plus 2, x plus 5, because that's just a simple ABC. So I've got quite a few things to show you today. I have a feeling that you're not going to like it because it involves working with fractions. But it's going to be on the test, so we just have to deal with it. So before we start doing the actual problems, I just want to review switching back and forth. So, yeah. Put it higher?
Yeah.
Like right there?
Yeah.
Okay. So when we started the chapter, we first learned how to switch back and forth between the radical form and the exponential form. And we saw that there was a pattern. I also don't like writing my fractions like completely level. I like slanting them because then the top one is the exponent to the base, the bottom one is the index. So in this illustration right here, this is just a reminder of like what everything is called. The most important ones that we need to know are the index and the exponent. So the index is b right here on the radical. That's the rule on how to break stuff out. Now the connection you're really going to have to make today is that's the same thing as the b that's on the bottom, because we are kind of expected to simplify it, whether it has the radical or if it has the exponents as a fraction. Now I'm not going to lie to you. Like if you like it using the radical way better, you can always just change them to that way. So I'm just going to review with you how to like convert back and forth. So this is just review right here for now. So to go from exponential form to radical form, you have to remember. Let's see what we got here. Remember will be the power. So we've got. Remember that the denominator. If you don't like the word denominator, you just put the bottom. That's what it is. It's the bottom of the fractional exponent. That's going to become the index. And then the numerator, or the top, that will become the power. So for me, I don't like seeing the fraction like that, so I always write over the problem, and I go like this, because to me, it makes it easier to remember which is which. So since the 1 is closest to the 3, that means it's 3 to the 1, and then we put the radical, and then the bottom becomes the 2 on the little step. Now, this is the only radical where you don't actually have to put the 2, because it's already understood to be a 2 when it's blank. And then the next one, you have 7 to the 3/4. So I slant it, so I can see the 7 is closer to the 3. So 7 to the 3rd, and then we have the 4th root here. So when we have a negative, I think that's a negative. When we have a negative, the negative doesn't go to both. It only goes to 1. And what I want to do with you guys is to be consistent. Let's always just put it on top if you see a negative. And later on in the lesson, we're going to fix negatives anyway, so you don't have to kind of worry about that much. But we're going to scribble this out and just put it on top. That was ugly. Hold on, let me do it again. Scribble it out, and then put it on the top number. And I'm going to slant that, so it's like this. So this is x to the negative 3rd, and then radical. Another reason why I did that is because there's no such thing as a negative root. So it has to go on the exponent. And then the last one has this entire parentheses. So we copy down the entire parentheses, and I can still do the slanting thing that we talked about earlier. So the 1 belongs to the entire parentheses, and then the radical goes around the entire parentheses also. So that's converting. The reason why we need to convert is because if you don't like working with the fractions, you can always just change it to this and then do the prison break stuff that I told you about 2 days ago. So that's going exponential to radical. If you guys will turn the page, the next page has radical back into fractional or exponential. And the only reason I'm doing this is because the instructions on your assignment are going to say to switch it first and then simplify it. So we're doing how to switch back and forth. So now we're going from radical to exponential. So remember that when you have the radical, the index of the radical is going to become the bottom of the fraction. You can put denominator if you want. And then the exponent becomes the top of the fraction. So when we did this the first time, I showed you problems that didn't have numbers, but you're supposed to understand that, for example, on this radical, that number is a 2 when you don't see it. We also need an exponent, and when you don't see an exponent, it's a 1. So this problem, when we convert it to the other form, it would become 6 to the 1 over 2. And hopefully after doing this a bunch of times, you'll just start to understand that when you see a 1/2, it just means radical or square root. So for example, if I saw 36 to the 1/2, the answer is 6. Because the answer is the same as square root 36. Same thing on part B. Part B has a little 2 right here. So we take the entire parentheses, 5AB, and that 3 stays there, and then I put the index at the bottom. Now we're going to have to do some stuff with this, with these exponents and with the radicals. So we have to remember some of the rules that were on the last test. Did you guys notice when you were taking the test, all the rules were right here? I left them on board, trying to trip you up. I don't know if anyone saw that, but I did that on purpose. But these are the 3 main rules you're going to have to know when we work with these things. You're going to have to know that when you multiply 2 things together, you just add their exponents. In your assignment, they're going to be fractions, but that's not an issue because you can just type the fractions in the calculator. You need to know that when you have multiple things in parentheses, that exponent distributes to every exponent that's on the inside. You're going to have to multiply exponents that are fractions with whole numbers. That's not a problem because you can always type it in the calculator. And then you just have to remember how to fix negative exponents. We fix negative exponents by figuring out where they are in the current fraction and then just moving them to the other location. So this one is on top, so I move it down to the bottom. So following the directions, it says rewrite each expression in radical form and then simplify if possible. So the first thing I want to do is slant this right here so I can figure out how I can write it a little easier. So we're going to take the 62x, and I'm going to kind of leave it in the parentheses, and I'm going to put the 1 on the exponent, and then I'm going to take the 4th root of that. Now, an exponent of 1 just means you have 1 copy. A 1? It's because of the rules that we learned on 6.1. The top is the exponent, and then the bottom is the index. So I'm going to show you some things about breaking this down. When you guys break this down, This exponent, we actually don't really have to like work it out. Like if it was a 2, I don't want to know what 62 squared is, because when I break it down to try to break it out of prison, I have to think what times what gives me that number. So instead of doing that, I would just write a copy of 62 twice, because we're going to have to do that anyways. So this one right here, this one goes to the entire parentheses, so it just means you have one copy, so we can actually start breaking this down. Since we don't have multiple copies, we can just break down the stuff that's in the parentheses. So what times what gives us 62? It's got to be 2 and something, right? 2 and 31. Okay. 2 and 31. So I think 31's a prime and 2's a prime, so they don't go anymore. So there's nothing we can take out. So this would be our answer. So this right here, it says to simplify, but it also says only if it's possible. So in this problem, it's not possible. So the next problem, same thing. We've got 32 to the 32y to the third. It's got a 1/2. 1/2 means this. So I'm going to rewrite it first as 32y to the third. That's all to the 1. And then we have a radical of 2, or the square root. Now again, guys, if that exponent is a 1, you don't really have to do anything different. You can just start breaking it down. So what times what gives us 32? 8 and 4. And then 8 is 2 times 4. Now guys, I want to show you something. Isn't this rule to break them out in 2s? I already have a pair of 4s. If you continue to break it down, that's okay, but then you're going to have 2 groups of 2, and so it'll still be 2 times 2 anyways. So if you catch that you already have the pair, you can actually just take it out right away. So the 4 comes out. Now the y to the third, it says there's 3 of them, so these come out. So a 4 and a y come out, and then everything that's not circled, that goes back in. So I have a 2 that's not circled, and I have a y that's not circled. So that just goes back in. Now I got a question for you. How come I didn't include the 8? There's an 8 up here that's not circled. How come I didn't put the 8 back in here? Yeah, it's not that it doesn't have a pair. It's that 8 isn't really there anymore because it broke down into 2 times 4. So when we look at our numbers to try to break them out, we only use the numbers at the end of our branches. So they'll be at the very bottom of the factor tree that we're making. So that would be our answer. The next one says 27b to the negative 1/3. Now, what I would advise you to do is let's just fix the negative first. To me, that makes more sense. So watch this. Right now, this is all on top of a fraction. So to fix it, I'm going to put the 27b on the bottom, and then I'm going to make this a positive 1/3. So you can just fix it right away. Then we can convert. So I've got, let's see, 1 over, I'm going to have 27b. This is all to the first power. And then we want a cube root. So again, it's just to the first power, so we can just immediately start breaking it down. So 27 is 9 times 3. 9 is 3 times 3. Our index is 3. So that means that we want to take them out in a group of 3. So I've got 3 3s here. So that's a single 3 that's going to come out. Then I have b to the first power. Now b to the first power is just b. So it doesn't have any, I don't have a group of 3, so I can't take it out. So that stays in. So the b stays in. This is the third root. And don't forget, this was all on the bottom. So that's our answer. So we have to rewrite it in radical form and break it down. And then we should also be able to do it in exponential form. So now we're going to do it the other way. So now they give us radicals, and they want us to write it with exponents. So the first thing I'm going to do is I'm going to take the 7a, and because it's kind of together, I'm going to put it in the parentheses like this. I'll put the slant right here, and so the 4 has to go on top, and the 3 has to go on the bottom. Now let me explain to you what this means. Sometimes you can break these down. Well, actually, let me say it this way. Out of this fraction, this is the most important number that we need to look at, because that tells us how many copies we need in order for us to take out one of the groups. So, Don, I have a question for you. How many copies of the 7a do we have? Yeah, there's 4 copies. So think about this. That top one is the exponent that goes with this, so it means this: 7a, 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 7a. The bottom is how many we need, like how many copies we need in order to take one out. Let me rearrange this so you can see all the 7s together. There's 4 7s, and there's 4 8s. So the rule is right here: take them out in groups of 3. That's what the fraction means. So I've got a group right here, so I can take out a 7. I've got a group right here, so I can take out an A. But I have some stuff that can't come out. So what we do is we put them back into the parentheses, 7a, and then we have to put the fraction here. The fraction has to have a 3 at the bottom, because that's what the original one had. And then what would the exponent on the top be? It would just be 1. Perfect. There's 1 copy of a 7, and there's 1 copy of an A. So that would be our answer. So don't forget, this part in blue, it means that it's in the radical still. So like when we talked about that prison stuff, that's the stuff that's still in the prison. This stuff right here in red, that's the stuff that came out of the prison. I'm going to show you that to you again because it's kind of confusing. Okay? So we're going to take this entire problem right here. 125 x to the 3. And I'm going to take that problem and I'm going to write it to the 1/3 power. So if you notice the exponent on the top, the exponent is a 1. So that means all we have is this copy right here. We don't have multiple copies of it like we did here, so I just write it once. Then I'm going to try to break it down. So 125, what times what gives us 125? Well, guys, if it ends in a 5, I hope it's 5 times something, right? 5 times 25. So this is 5 times 25. And then this guy right here breaks down into 5 times 5. So remember, I said this guy right here, this is the most important one because that's the rule on how you break them out. So there's 3 5s. So that means a 5 comes out. Then we also have the x to the 3rd. X to the 3rd means there's 3 x's. So there's our group of 3. So the x also comes out. So I don't have anything left. That's my answer. Yeah. What do you mean? Yeah. I got the x from these 3 x's right here. There's 3 of them because the rule is to break them out in 3. So there's 3 copies. So every time I circle one, I take one out. There's no way we're going to have a problem that has letters in it in the original problem, and in the end we don't have letters. They don't disappear. So if the problem has letters, the answer is going to have letters.
What's the whole point of having the letters to the side?
What's the whole point? I just wanted to show my work. The work for the 5, that's the 125 stuff over here.
No,
the 3 5s.
the x, what's the whole point of doing check?
Well, I want you to see how many x's there are because the rule is to break them out in groups of 3. This is x to the third, so I just wrote them out so you can see them. Yeah, because the bottom of the fraction is the rule on how you get to take the stuff out. Because the bottom number is a 3, I wanted you to see that there was 3 of them. Because if there's 3 of them, we're allowed to take one out. Okay, this next one. I should have put more space, but that's okay. So the next one. I have, let me turn it into the fraction first, so 8x to the 4. And this fraction is going to say 5th power, and this is going to say 6. So here's how we handle this problem. I kind of wish that exponent wasn't so high, but whatevs. So watch this. The exponent of 5 means that there's 5 copies. So I have 8x to the 4, 8x to the 4, 8x to the 4, 8x to the 4, and 8x to the 4. Are you guys with me so far? The top number tells you how many copies you have. So I just wrote it out. The bottom number tells you how many copies there needs to be in order to take 1 out. So could I take an 8 out? There's 5 of them, and the rule is to take them out at 6. So I can't take an 8 out. So what we need to do is break it down. Now, let me see if this makes sense. Should I break down all 5 problems? No, because they're all the same. So all we have to do is do it once, and then we can kind of just think about how we break down for the rest of them. There's just going to be 4 extra copies of it. So let's break down one of them. Oh, and let me also say this. In this fraction, if the top number would have been higher, we would have been able to take out one of the 8s. Because that means there's more 8s than there are, like how we're trying to break down our groups. So if that top number is ever bigger, you will be able to take it out without having to break down the individual part. So let's break down this individual part. So this right here is 4 times 2. And this right here is 2 times 2. So that one problem right there is 2 times 2 times 2. And then for the x's, it would be x, 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 and x. Now we want to break them out in groups of 6, right? So if this problem is the same exact answer, doesn't it kind of take 2 of these to be able to break out some 2's? So I'm gonna just imagine, because I'm too lazy to write it. I'm gonna go like this. And I'm just going to imagine that there's 3 2's right here, because I know there's 3 2's, because all of these have 3 2's. So that's for this one. And then these 2, I'll be able to take out another set of 6. And then this one has 3 2's left. Are you guys following me? Because it's confusing a little bit. And it's not that big a deal. If you want to write them, I don't care. Write them. So there's 2 2 2, 2 2 2, 2 2 2. The rule is take them out in 6's. So I take out a 1, 2 from the first circle. I take out 1, 2 from the second circle, and I'm multiplying them as they come out. Now let's think about these x's. This has 4. This has 4. Each one of these has 4. How many are there altogether? There's 20, right? So if I have 20 and I want to make them into groups of 6, how many groups of 6 could I make if there was 20 of them? I should be able to make 3 groups. So this would be x to the 3. So if I made 3 groups of 6, that's a total of 18, right? But you told me there was 20. So how many are left? There's 2 x's left. So why 2? Remember, we're making them in groups of 6. We said there was 3 groups of 6, so that x to the 3 right there, that counts for 18 of them. But there's 20 of them altogether because each one of these groups of 2 has 4 x's in it, and there's 5 sets of those, so there's 20 altogether. So we have 2 x's left, and then we have the 3 2's left. So we just multiply them all together and put them back in. So that right there is 2 times 2 times 2 is 8. Then we had 2 x's left. And the rule was, oh, hold on a second. Oh, this has fractions. I have to leave it in fractions. My bad. So instead of writing it like that, I'm going to put it as a fraction. 8x squared. So we're going to say we got 1 copy of this, and we want to take them out in groups of 6. So our final answer here would say 4x to the 3rd times 8x squared to the 1/6 power. Hey guys, if it really comes down to it, you can write it all out if you want. I was just trying to take some shortcuts, but that's a lot of x's. I don't want to write 20 x's. Okay, on the last page. Wait, is there another page? Okay, let's do this one. Okay, so in this problems, or on these problems, I should say, it says rewrite with positive exponents and then simplify. Let's start off, yeah, let's just do the first one, whatever. So, how do you fix a negative again? Okay, you just flip it, right? Now, you guys have to also remember this stuff. This exponent is going to distribute to everything. So, isn't it going to turn every exponent negative? So, wouldn't we be able to fix it by just switching everything first? If I take the 16 y to the 1/4 and put it on top, and then take the 81x and put it on the bottom, that actually fixes this exponent over here. Now here's where some other rules come into play. I told you that we have to multiply exponents when you have an exponent on the outside. So we have to take the 3/4 and multiply it to every single exponent here. So this would be 16 to the 3/4. This would be y to the 3/16. This would be 81 to the 3/4. And then this would be x to the 3/4. And if you're not sure how I got 3/16, it's because when you multiply fractions, you do the top with the top and the bottom with the bottom. So now we have to look at this as individual pieces. This is like 4 different problems. We need to see if we can break this stuff down. Let's take the 16 to the 3/4. 16 to the 3/4 means we have 3 16ths. I want them in groups of 4. So what times what gives me 16? Oh, I like that one, because watch this. If I do them as 4s, don't these all have 4s? Right? And we want them in groups of 4. So right away, I can take these out. So that 16 is going to turn into a 4. But wait a second. Can we break these down some more? So that part's going to give me 4. These would break down 2 and 2, 2 and 2. And the rule was to take them out in groups of 4. So now we've got a group of 2s. So I can take that and multiply it with the 4 we took out. So that 16, it just turns into 8. And then we can do the same thing with the 81. The 81 says there are 3 copies of it. So 81, 81, 81. And when we break them down, let's break them down so that they already have like matching numbers. Because that's our ultimate goal, is to get them to match so we can break them down. So again, we're taking them out in groups of 4. So I can take out a 9 from there. And since there's only 2 here, I can continue to break those down. 3 and 3, 3 and 3, and there's a group of 3s. So this would give me a 3. So 9 times 3 is 27. Take a look at the y's. Would you be able to take any y's out? How many y's do we have? How many do we need to group them? 16 of them. So I can't do that. That just stays. So this would be y to the 316. How about the x's? Do I have enough to take them out? No. The only way you can take them out is if these numbers are like tied, like 4 over 4, or it's higher on top. If the bottom number is bigger than the top, you can't take anything out. So this would be x to the 3/4. So that's your answer. That right there, that's like the worstest problem ever. There aren't that many like that, but that's the one that has the most work. The rest of them, they're not that bad. So let me show you these other ones. So right away, it's got a negative. So let's fix it first. If it has a negative, I'll put it over 1 like that so you can see it's on top. So to fix it, we would put it like this. 1 over 243 to the 4/5. So 243, man. 243, we need 4 copies of that. 243, 243, 243, 243. So what times what gives me 243? 3 and what? All right. Now I like that because 3 and 81. What are we doing? These groups of 5? So 3 and 81, 3 and 81, 3 and 81. Do I have anything that can come out yet? Not yet. So I got to keep bringing it down. So 81 is 9 times 9. 9 times 9. 9 times 9. 9 times 9. Can I take anything out now? What can I take out? So we're doing them in groups of 5, so that means right here I can take out a single 9. Now I have this 3, I have a bunch of 3s right here, but I don't have enough to take them out, so I got to break these 9s down some more. So I got 3 times 3 here, 3 times 3, 3 times 3. So I need them in groups of 5. So let's see, 1, 2, 3, 4, 5. Here's a group of 5. So there's a 3 that can come out. I have 1, 2, 3, 4, 5. So a second 3 comes out. So this answer, 1 over 81. So can I take a second to make you angry? Do you guys want to get angry? Want to get angry with me? Yeah. That's how I convince my dogs to do stuff. Do you want to go to the park? Okay, so check this out, guys. Guys, listen to this. Are you ready? Lean in. I think you're going to like this. If you see a problem that doesn't have any letters in it, you know how you could also do it? Well, it's even easier than that. If you see a problem that doesn't have any letters in it at all of you have some magical device on your desk right now. You know what I'm saying? You get me? If you see a problem that has only numbers in it, you could actually just type the thing in your calculator and do it for you. The only problem is, if you get a problem that has leftovers, it will not show you the leftovers. It'll turn it into a decimal, so then you will have to do it by hand. So if you would have just typed 243 to the 4/5, you would have got 81. Are you mad? Okay. Last one. Oh, almost the last one. Man, it's taking forever. Good thing we got a weekend so you can do all the homework. I've never heard someone be mad about the weekend before. I'm going to actually cut the homework in half, so don't panic. Okay, so this one. You got two things inside, and you got an exponent outside, so you just got to times them. And you can do that in the calculator. So 2/3 times 6. 2/3 times 6. I think that's 4. So this is x to the 4th. And then negative 1/3 times 6 would be negative 2. And then what we learned in the past is we're not supposed to leave our answers negative with the exponents negative. So this is going to say x to the 4 over y to the 2. So the first two were brutal. Number 2, you could have just done with the calculator. This one is actually not that bad. Do you guys think if I showed you a test question, you would know how to do it for the test? Okay, because that's what the next two are. Straight from the test. So let me show you this right here. And then let me see if I can get you guys to understand this first. If I have something that says 2 to the 5th equals 2 to the x, can you guys tell me what x equals? You said 5. How do you know that? It's kind of obvious, right? Everything here matches. If you look at the twos match, so you can kind of ignore those. So that means x equals 5. So our goal in these problems right here is going to be to use the facts that we know, including the exponent rules that are on the board behind me, to turn this into a single x. So let me tell you the strategy. First of all, you see how that one's in radical and that one's in the fraction? We should have them all in fractions first. So let's take the top one and turn it into a fraction. What would the top one be as a fraction? It would be x to the 1 over 5. And the bottom is already in a fraction. I like that. I like that right there. You guys ever seen Root Radio? I like how he talks in radio. It's an old movie, you find our song. Whatever. Okay, so isn't it also true that when you have two bases that match, you can just subtract the exponents? You guys remember that rule? It was on the last test, and it's behind me. It's this one right here. If I have them in a fraction, I can just write them as 1 and then subtract the 2 exponents. So I can go like this. X to the 1/5 minus 11/5. Now, that can be done in your calculator. 1/5 take away 11/5. It's going to be negative. Well, it would be negative 10/5, right? Well, what's 10 divided by 5? I gave you the answer, yeah. So we just took this big, fancy, ugly thing, and we rewrote it so it has just an x, a single x. And that's exactly what we needed to happen in order to figure out what this y needs to be. So you know what y is now? Y equals negative 2. Because if you can get the bases to match, if you can get these two bases to match exactly, then whatever's in their exponents are going to be equal to each other. I'm going to show you the last one. We might as well. We're 45 minutes in. We're going to do it all. Okay, so I don't like to see parentheses. I don't like to see radicals. So let's use the rules here. What do I do with the 4 and the 1/3? Multiply them. So this is x to the 4/3. And then on the bottom, I don't like to see the radicals. So I want to convert that one to the fraction. That would be to the 4/3. Now using the subtraction rule, what's that going to give us? Hold on. What's the exponent going to be? Guys, 4/3, take away 4/3. It's just 0. And I think you guys were telling me 1 because anything to the 0 is 1, right? But we actually don't want the 1 because our goal was to make the basis match. Guess what y is? Yeah. Y equals 0. I understand, yes, x to the 0 gives you 1, but that's not our goal. Our goal was to make these both say x to the something. Once they both say x to the something, then here's the answer right here. Y equals 0. Guys, that's a test question. Like there's one just like this on the test. So think about what we did. If there's fractions, get rid of them. If there's radicals, get rid of them. Once you have the two fractions, subtract them, and then these should match, and then you can just set the exponents equal to each other. As hard as that question looks, it actually isn't that hard. You're just using all your facts that you're supposed to know about this stuff. Let's see. So for the homework, I did the answer key already, but I did every single one because I didn't know it was going to take this long to do all these questions. So for the answer key, no, not the answer key, for your homework, let's just do the evens. There's like 28 questions, so you'll just do 2 through 28 evens. So it's like 14 instead. It's a little bit of everything though, because there was a lot of stuff I had to cover today.